Okay, in this video we're going to talk about Unit 9, Objective 3, which is logistic curves. Logistic curves are similar to exponential curves, except they're going to reach some maximum y value that they're going to approach with a horizontal asymptote. So what a graph of a logistic curve looks like is something that starts out increasing and concave up, growing exponentially, and then it starts to go increasing and concave down as it approaches some maximum, what we're going to call carrying capacity, and that's going to serve as a horizontal asymptote. So it's going to look something like this, where we start increasing concave up, then we go increasing concave down, and then we hit this horizontal asymptote. What we call that horizontal asymptote, like I said, is the carrying capacity. And the carrying capacity we usually call the letter M. So this could be our population axis, for example, versus time, and we have some M that we're going to call the carrying capacity that's going to serve as a horizontal asymptote. So our population can't grow any greater than that M. So how AP is going to ask about logistic curves is they're generally going to give you the derivative, the rate of growth of that population. So they'll call it dp dt, so the change in population over time. Now this is not going to be kp like it was in exponential. What it's going to be is that same kp times the carrying capacity minus the population. Now we don't have to solve this differential equation. We don't have to figure out what p actually is. The AP is going to ask you one of two things about logistic curves. One, they're going to ask about the limit as t approaches infinity of p of t. So that's the function, that's not the differential equation. But if we think about the graph, as we go towards infinity, as our graph goes towards infinity, we start to hit that horizontal asymptote of the carrying capacity M. So going back to what we knew about horizontal asymptotes, t goes to positive infinity. Looking at the graph, we got our carrying capacity, so we know that's going to be M. So that's how we're actually going to use our differential equation to solve the limit of p of t, because n is inside our differential equation. The other thing that they might ask us to do is find what the population is when the population is growing the fastest. Fastest. They might also say at what time is the population growing the fastest, but it's going to come down to something about the population growing the fastest. So population growth is in the question. So population growing, that's our dp dt. And then they want to know, when is that happening the fastest? So that's talking about a maximum. So whenever we see a question like this, we want to say that the second derivative of p with respect to time twice is equal to 0 and solve that maximum problem. So we're going to take the derivative of what they give us, solve it for set it equal to 0 and solve, and then we're either going to get the population or the time depending on which one they're actually asking for. So those are the two things that they can ask about logistic growth, so we'll call it quits on this video and we'll see you in the next one.